So today we are going to learn how to write proportions. Last week we talked about how to solve them. Now we're going to learn how to set them up. This is a continuation of chapter 1, lesson 6, if you need to look anything up. A real quick reminder, a proportion is two equal fractions. And we know that they have the same thing, the same relationship, the same amount of change. When we start talking about things being proportional, that word same comes up a lot. Okay, a lot of times we're talking about a smaller group leading to a bigger group, or a smaller piece and a bigger piece, but the relationship between things is the same. Okay, if you are a fan of colored pens, this lesson is for you. I love using colored pens for this because I think it makes things really easy to see and how you set them up. The other thing that I'm going to caution you, there are multiple correct ways that you can set up a proportion for the same problem. And I'm going to show you a way to check so that you don't always have to say, oh, but is mine the same? I'll show you. All right. So my biggest hint is that the same stuff has to go in the same place. That doesn't mean anything to you at the moment, but very quickly it will. The same stuff, the same label, the same type of information needs to go in the same position within the proportion. All right, so let's look at our first problem here. Olivia bought 6 containers of yogurt for $7.68. How much would 10 containers cost? And we're going to assume that the price is going to be the same. That isn't always true. Sometimes the more you buy, the cheaper the rate you get, but usually it's like a lot more. Like you'd have to buy like thousands and thousands of containers of yogurt to get a better price. So we're going to assume it's the same for each. Let's set up the basics of the proportion. I call this line equals line because that's exactly what it looks like. It's the 2 fraction bars, since I've got 2 equal fractions with the equal sign in the middle. All right, so line equals line sets up those 4 places that you have to fill in. Now, let's think about the 2 things that could change in our problem with Olivia. We could change the amount of containers in her cart, and we could change the price that she's going to pay. Right? So each fraction is going to contain one of each of those. It's going to contain a container, it's going to have a container, and it's going to have a price. All right. The easiest thing I can tell you to do is just start. Now, this is her original. I'm going to do this information in light blue. And this is her what if, and I'm going to do that information in red. Okay, I think sometimes when you circle it, it kind of helps everything pop. So just start. Look at my blue. The first number I see is 6. I'm just going to put it there. Now, what is 6's partner? This is 6 containers. Okay. What is the other thing with the original purchase that she made? It's money, right? So I'm going to put that $7.68 on the bottom. 6 containers for $7.68. And then I'm going to put my blue pen down because I'm done with it. Now, when I get to the red pen information, the second set that I've circled, the containers goes on the top. So like we said, same stuff, same place. Which one of these numbers, the 10 or the variable, is the containers? It's the 10, right? So since containers goes on the top, my 10 will also go on the top. Now, the cost, we don't know. So pick a letter. C for cost, X because that's the one that we always go for, your first initial. I don't know that I'd use O for Olivia, maybe L for Liv. I'm going to go for X. I'm a math geek at heart. Congratulations, you have just set up your first proportion. And then you would solve it the same way we did last week. Look for your diagonal, multiply that, and then divide them. I'm not going to solve them just yet because I want to show you another way that you can set this up. All right? There's always somebody, when I do this in person in class, there's always somebody that goes, but Mrs. Milichowski, I set it up differently. And then we have to sit there for 5 minutes and explain how we do things differently. And then another person says, but I have something different still. Okay, let's talk about this. Let's go back to our blue. I'm still going to put my 6 containers right here. But instead of putting the money underneath it, I'm going to put the money next to it. I know, I'm being a rebel. It's okay. because the same stuff from my first situation is still in the same place. They're both on the top, and that's okay. Over here, they were both on the left. That's okay. They were in the same spot. So now when I go to do my second set of information, this was containers, which means the 10 goes underneath of it, and my I don't know goes over there. First set on the top, second set on the bottom. Same stuff, same place. That is okay. Containers and containers, both on the left. Money and money, both on the right. That's okay. Originally, we had first set on the left, second set on the right. Containers and containers on the top, money and money on the bottom. That's actually okay. How do I know that these will give me the exact same answer? Look at the diagonals. When you go to multiply, what is it that I'm multiplying? In both cases here, it's going to be 768 times 10 and 768 times 10. If I go the other way, it'd be 6x and 6x. The resulting equation is exactly the same for both of these. So when you have something that looks a little bit different when we're creating these proportions, double check the diagonals before you say, but I have something different, because yours still might get the job done. Okay? Let me ask you a question. What if, I'm going to do this all in the same color. What if I did this? Is that an equivalent proportion? Is that okay on how I set it up? Check the diagonals. Are 6 and x still diagonal? Whoa, no, they're not. That is not an okay proportion for this problem. Okay? All right, so let's do this multiplication. We're going to do 10 times 768, and we get 76.8. And we're going to do 6 times x and get 6x. And then we're going to divide both sides by 6, 76.8 divided by 6. And I get x equals 12.8. Now that's money. Don't leave it as 12.8. You know that money gets a 0 in the end. Okay? So if she was paying the same price, we would expect this to cost her $12.80, which feels about right. We're not quite double, so we're not quite to 14. Yeah, that seems reasonable. Okay? All right, let's go into another problem. And I'm not going to do this both ways. I'm going to make this go a little bit quicker now. Let's start off. I know it's going to be a proportion problem because that's what I'm dealing with. So line equals line. Set that up. Okay. JC typed 2 pages in 15 minutes. How long will it take her to type 10 pages at this rate? Now, I know you just all multiplied that by 5 in your head. I get it. What a beautiful thing that you have another method to check yourself while you're learning this. Use that. Use that to your advantage. Okay, I grabbed my blue pen first. So her short paper was 2 pages in 15 minutes. And her long paper will be 10 pages, I don't know, at this rate. I usually don't circle the whole thing for that. So let's go to the blue. If I do 2 pages, I'll do that on the top. And 15 minutes, I'll do that on the bottom. I personally like to do the fraction together on the same side, but it doesn't have to be. All right, when I go to my long paper, the pages were on top, so the 10 will go on the top. And we don't know the amount of time. There you go. Now, if you set it up differently, as long as your 15 and 10 are diagonal, and your 2 and x are diagonal, you're good. Of course, when we go to multiply this, we'll get 150 equals 2x. Divide both by 2, x equals 75 minutes. I know that's an hour and 15 minutes, but 75 will work too. All right, this last one is actually 2 proportions snuck together, right? Because there's 2 question marks. So let's see, Scott earned $28.50 babysitting his cousin for 3 hours. So $28.50 for 3 hours. Assuming his rate is the same, how much would he get for 2 hours? I don't know how much for 2 hours. Oop, oop, oop. Nope, That should have been in red. Sorry about that. These erasable colored pens are amazing. And then I'm also going to do it with a green pen because there's 2 questions. Okay, so I'm going to set up 2 different proportions, one at a time. All right, so 28.50 for 3 hours. Labels can be really helpful for this too. Okay, now how much, so that's where the X is going to go, for only 2 hours. Should have done that in red. I don't know why I keep doing this at the same color. It's because I put them down. If I had them in my hand, I would have switched. There we go. The colors really aren't necessary, but I really think they help you see it, right? All the blue stuff went here. All the red stuff went here. Now, if you're on a roll and you want to set the other one up, set the other one up at the same time. So the 28.50 stays the same. And the 3 hours stays the same. That was the original that I'm comparing this all to. Now, I don't know how much you'll get for 4.5 hours. And you can see I switched colors just because. All right. Now, there is a trick to solving these that I told you I would share, but I didn't want to share last week. You're doing the exact same thing. You're just not writing out this equation. Please make sure you understand what this equation does. This is the formal way. It will be necessary for some of the more difficult, challenging algebra problems that we do later in the year. But for something like this, cross multiply and divide by the other number. Find the diagonal that has 2 numbers, not the variable. So in this case, it would be 28.50 times 2. 28.5 times 2 equals. And then simply divide by the other number. So in this case, we expect Scott to get $19 for 2 hours worth of work. And then a similar thing here, 28.5 times 4.5 divided by the other digit, we get 42.75. Not bad for a couple hours of work. Right? Of course, there are other ways to solve these problems, but if you know something has a same consistent rate, use proportions. It's really fast, and once you get the hang of it, it's real easy to change things out. You know, what happens if the setup is essentially the same? You just swapped out the numbers here. Okay?